Hello students, today we will discuss regarding EHV transmissions. So what is EHV? EHV stands for extra high voltage transmission. Okay, so your EHV stands for extra high voltage transmission. So first question reads here, why we are preferring high voltage for transmissions? Okay, so as we know, when we are stepping up the voltage with the transformer or when we are choosing high voltage for transmission, that means for the same amount of power we are reducing current. So your equation for power, so what is your equation for power? So your equation for power is P equal to VI. When we are stepping up voltage, that means we are reducing the current. So the your losses is reduced when we are choosing higher voltage for transmissions. So what is the major advantage? It reduces transmission losses. So and when we are talking about EHV transmission, so voltage ranges from 400 kV to 765 are generally considered as extra high voltage transmissions. Okay, so largest voltage in EC lines. This is for the AC transmission systems. So most of the transmission network in nowadays uses in our country are in AC. Okay, so generally, EHV AC lines selected for the long distance above 250 kilometer and higher power above 5 megawatt. Okay. So why we are not selecting EHV transmission for the lower distances and lower power? The reason is just simple: cost. This is not, if we will choose EHV transmission for less than 250 km and less than 500 megawatt. This is not hard and fast. This is roughly around 250 kilometer and 5 megawatt, 500 megawatt. Then if we will choose lesser distance and lesser power for EHV transmission, that means it will be not economical. So economy is one of the important aspects in engineering. If you are designing anything that is not economical, it will be not sellable in market. Concept is clear. Okay. So this is elementary idea about your EHV transmission. So what are the reasons why we are adopting EHV transmission? So first is increase in size of generating unit. What happens in nowadays, demand is increasing rapidly. So same time, in same pace, our generation is also increasing. So for transmitting large amount of power over a large distance, it is technically and economically, EHV transmission is the best way. So it can be technical. If you are considered technical parameters, if we will transmit voltages at lower, we will transmit power at lower voltages. That means your losses will be more. First thing, and also you will compromise with overall cost of generation. If when we are increasing transmission voltage, that means generating cost per unit is reduced. Okay, thing is simpler. Second reason why we are adopting EHV transmission, your peak and steam power plants and peak steam power plants and remote hydro plants are generally located far from the load center. So hence transmission of large amount of power over long distance. It will be only feasible by EHV transmissions. If you will transmit it at longer voltage, then you maybe see there is around 60 to 70% losses, and you are only transmitting only 30% of power. So, same time, cost will be increased accordingly. Okay. So, and third point is cost of transmission. So, line installation cost per megawatt per kilometer decreases with with increase in voltage level. Uh, yes, but we cannot increase the voltage beyond a certain limit. So, if I have told in India there is 765 kV highest voltage. So, what are the reasons we will discuss in later slides? Problems involved in EHV transmission. What are the problems involved in EHV transmissions? First one is your corona loss and radio interference. Yes, if your voltage level will be rise, that means there will be more corona loss. Why more corona loss? There will be more potential gradient, that means more ionized particles, that means more corona loss. And it will be also some problem also arises. It will be interference from the neighboring communication lines, radio and television lines. If we are increasing the voltage, okay. We are not, we can say, just for increasing the voltage. In generally AC lines, the interference is occurring with the communications line. Okay. And what are the second problem? Heavy supporting a structure and erection difficulties. And from my point of view, this is the major concern. If you are increasing voltage, so you have to design all the structure accordingly. Your tower structure, your insulators, your cross arms, and all the things you have to design accordingly, and all will be the size of the support structure and auxiliary equipment is so bulky, so it may not withstand mechanical pressures or mechanical load. So there is written, generally EHV transmission uses bundle conductor. This results large mechanical loading on the tower. Similarly, large air and ground clearance. Yes, you have to put the ground clearance as per your voltage level. So as earlier class I have already told these things. So clearance is decided on the voltage level, not current level. So if voltage is higher, that means clearance is higher, your length of tower is, or your height of tower is larger. Okay, so your tower strength should be high. And insulation requirement, obviously, in previous point I have told, your clearance is depends on your voltage level. That means clearance means what? A safe limit for transmit the power. Means you have to place the conductor at which distance where power can transmit safely. It cannot hamper the living things and other things on Earth, on the surface. Okay. So in third point, insulation requirement, it's also depends on your voltage rating. If your voltage rating is high, that means your insulation needed is high. So your size of insulator will be increased, and accordingly each and everything will be increased. Sure. Yes, obviously. And generally, HVAC transmission require high insulation pipe. This is also one of the reasons to withstand the voltage surges due to internal sources. Due to internal sources means what are the reason for the voltage surges due to internal sources? You are switching fault. So we have to put or we have to adopt higher insulation level. Okay. So this is up to previous slide. I have studied about EHV AC transmission. EHV AC transmissions. Okay. In this slide, I will discuss about HVDC transmission. I will discuss about HVDC transmission. Okay. So you may not heard this term. So HVDC transmission is a stands for higher voltage DC transmission. That means you will see, say we are using power in AC form. So how the transmission occur in AC? Yes. So what we are doing, I will discuss it later. I discuss in later slide or next slide. Okay. So So why be, yes, HVDC, that means what I have said, high voltage DC transmission. So yes, is it transmission occurs in DC? Yes, in nowadays transmissions occurs in some places in DC, in India also, in Odisha, the place is called Kanya to Kolar, power is transmitted in DC. That is your HVDC line, where 500 kV is the power is transmitted over the voltage 500 kV. Okay. So why we are adopting HVDC? Why we are adopting HVDC? What are the advantages of HVDC? We will discuss in later slides. Okay. So here we will see what are the features and what are the technical features in HVDC transmission. So generally, high voltage DC transmission required converter station both and sending and receiving end. The converter stations are transformer and thyristor bars. What happens? Yes, we are generating power in AC form, AC, but we are converting into a DC and transmitting it in form of a DC, but and also it converted into AC at also it converted into AC at receiving end station. Okay, so receiving end station and it is distributed to the consumer. So in converter stations, basically what we are using, yes, first when we have to convert AC into DC, we are using rectifier, and when we have to use DC into AC, that means your inverter. So at generating a station, your converter station works as a rectifier, and receiving in stations, your converter station works as a inverter. So each converter can function as a rectifier or inverter. So thus power can be transmitted in either direction. Yes, each converter station can be function. This is one of the important features. Converter station can be function as a rectifier or inverter. Yes, you're generating in converter station can also work as a rectifier and inverter, and your receiving end converter station also can work as a rectifier and inverter. Thus power can be transmitted in either direction. Okay. So this is the single line diagram of HVDC transmission. So here you can see the power is generated. There you can see you can see power is generating, and it is a step up by a step up transformer. Then in converter station, it is converted into DC, and through the HVDC link, it is transmitted over a long distance, and receiving it in the station. There is also a converter station where it is in again converted into AC, and it is distributed to the consumers. Okay. So this is the typical line diagram of HVDC transmission system. Okay. These are the HVDC links. Basically, we are using three types of link in HVDC transmission. First one is monopolar link, second one is your bipolar link, and third one is your homopolar link. Basically, in monopolar link, there is only one conductor that is negative, having negative polarity is present. And in bipolar link, there is two conductors of both negative and positive polarity are present. In homopolar link, generally two conductor having same polarity are present. That means generally both conductor having negative polarity. So yes, this is link is also important, but we will not emphasize so much on HVDC links because it is not in your syllabus. So let us come on next slide. Advantage. What are the advantages of HVDC or why we are preferring HVDC? Cheaper cost. Due to bipolar HV transmission lines require two conductor, which is very cheap. First thing. So yes, we cannot adopt HV as like EHV transmission. We cannot adopt HVDC everywhere. There is certain criteria for adapting HVDC. That means you have to you have to you have to transmit a larger or greater power, and at larger distance, like EHV. Okay, and it is beyond break-even point. So I will not go in details about break-even point. So in simpler way, first things, cheaper in cost. Yes, overall cost is also cheaper. But when power is transmitted over a larger distance and high amount of power is transmitted, then it is cheaper than your EHV AC transmission. Okay. Second is no skin effect. As you know, there is no skin effect in DC conductor. What is a skin effect? In case of DC, the tendency of charge carrier is flow on the surface of conductor. But in case of AC, in case of AC, the tendency of charge carrier is flow on the surface of conductor. But in DC, throughout the conductor cross-section area, same charge density that is. So there is no skin effect in DC. So due to skin effect, also losses is less in DC. And lower transmission losses because in DC system only two conductors needed, but in case of AC there are three conductors needed. Voltage regulation is better because inductance is not present in DC system, because in DC system only one parameter is present, that is resistance, inductance, capacitance. There is no existence of inductance and capacitance, and due to absence of inductance it has better voltage regulations. Line loading, generally loading of AC line is also limited by transient stability, but there is no such type of limit in HVDC. So it is also goes the favor of HVDC. And short circuit current, lower short circuit current, lesser corona and radio interference losses as compared to AC system. There is no radio interference basically because frequency is zero. Corona losses is also lesser. And higher operating voltage and no reactive power compensation. Yes. Operating voltage is also better, higher. Operating voltage is also better as compared to AC. And no reactive power compensation. Reactive, as you know, we are compensating reactive power. We are putting power compensator like a static capacitor, synchronous condenser. But in case of HVDC, there is no need of reactive power compensation. This things also goes the favor of the HVDC. No stability limit. There is no stability limit in transmission system. Yes, but there are certain limitation of HVDC transmission. What are the limitations? Costly terminal equipment. Costly, yes. we have to need converter station at both generating end and consumer end. So it increases the cost. So it is economical only when power is transmitted over a long distance at large amount of power. Okay. So why the cost increases here? Along with converter produces lots of harmonics, that is your power electronics equipment, semiconductor equipment, that is produce more harmonics for both DC and AC side, but both generating and consumer side, both side we have a converter station, and this requires filtering and smoothing equipment. This result extra additional expenses. And yeah, obviously, another thing, DC circuit breaking is also challenging. So circuit breaker is also costly. So these are the reason cost of terminal equipment is high. And more maintenance of line insulators. Yes, it's require more maintenance as compared to AC. As you know, circuit breaking is a not easier task in DC. It is difficult and costlier. Yes, third one is voltage transformation. Yeah, voltage transformer. We cannot use voltage transformer in HVDC transmission. This is the one. Yes, transformer is the region. Transformer is the region behind popularity of AC supply and big popularity of AC supply. We cannot use transformer in AC supply. That's why, sorry, in DC supply. That's why DC supply is not so much popular. So voltage transformation is not easier in case of DC. So it is can be accomplished on AC side of the system. So this is so what will be the major drawback? It cannot be employed for distribution or sub transmission and backbone transmissions. Okay, so this I hope this is all about HVDC transmissions. We have studied all those things. What are the advantages, merits, and what are the links using in HVDC transmissions? And so, thank you all.